Let's now immediately apply what you just learned here in coding challenge number 3. And in this one, I want you to use a constructor function to implement an electric car class. So a class that should be called EV and which will be a child class of the car class that we created in the first challenge. So in the first challenge, you used a constructor function to create the car. And now here, you're going to use the same technique to create the subclass. So basically the child class called EV. Okay? Now the EV, which stands for electric vehicle, by the way, also has a make and the current speed, of course, but it also has the current battery charge in percentage. And so that's here the charge property. And so here, in order to implement this child class, you will have to do exactly what we did in the last video. So basically connecting the two prototypes of these two constructors. Then on the EV class, I want you to implement a charge battery method, which takes in an argument called charge2, and it then simply sets the charge of the battery to that received value. Then also on this class, I want you to implement an accelerate method, which will increase the car speed by 20. And at the same time, it will also decrease the charge by 1%. And finally, this method should also print to the console a message like this. So the Tesla is going at 140 kilometers per hour with a charge of 22%. And that's Tesla here, because that's the test data that you're going to use here. So create an object based on this test data here, and then, just like before, experiment a little bit with the accelerate and the brake and also the charge battery methods. And one important thing that I want you to do is to notice what happens when you accelerate. All right, so review the definition of polymorphism that I gave you right in the first video of this section to make sense of this. So I hope that this is another fun challenge, and I see you here once you're finished. Okay, so let me start by getting the code that we wrote in the first challenge. So of course, there's no need to write it again. And so here goes my solution, which I hope you didn't need. But of course, it's always good to know how exactly I implemented it. So EV is this function, which has the same parameters as the car constructor. So that's the make and the speed, but then the additional property of charge. And so now, just like we did previously, we will not manually define the make and speed properties on the this keyword, but instead we will basically call the parent class. And so that's car.call, but with the this keyword that we are actually using in the EV. So we pass make and speed. And so again, this is exactly what we learned in the previous lecture. And then of course, we need to still set the speed. And now let's actually create the new car here. So the new object. So that's the new EV, Tesla going at 120, and the charge should start at 23%. Okay, let's take a look here. And the charge is not in there. Oh, yeah, that's pretty stupid mistake here. So of course, that's gotta be the charge. And so now it's all there. Okay, so that was the easy part. Now comes the trickiest part, which is to again link the prototypes. So we want the prototype property of EV to inherit from the prototype property of car. And so, therefore, we say object.create, which will create a new object. So it will set ev.prototype to the new object, which has as a prototype car.prototype. Great. And so now let's actually add some methods to the prototype of EV. So ev.prototype.charge battery. And this one is a function which takes in charge 2. And all it does is to set the charge to the charge that we receive here. All right. So let's experiment with this one. So Tesla.charge battery to 90. And so now if we take a look at Tesla here, it indeed now has the charge set to 90. All right. Now let's take a quick look actually here at the prototype chain. So let's see the prototype here. And so that, of course, now includes charge battery. Okay. And that in turn will contain accelerate and brake, which is the one coming from the car. And so one more time, this is exactly what we had in the previous lecture. So we had the introduce in the prototype of the student, and then in the prototype of the prototype, we had the calc8 method. And so here that is accelerate and brake. And so of course, we can now use that here. So we can say Tesla.brake, and then through the prototype chain, the Tesla object will have access to that. And so indeed, now it is going at 115 kilometers per hour. Okay, but now let's take care of number 3 here, which is to implement an accelerate method. So let's do that after the charge battery. So ev.prototype.accelerate. And this one will set the speed to plus 20, so it will increase it by 20, and it should decrease the charge by 1%, remember. So just like this, and then we should also log a console, so a string to the console, similar to this one that we had before. So it's going at the speed, and then with a charge of, and then this dot charge. Okay, so let's call that right after the brake dot accelerate, and let's see what happens now. And it worked just fine. So we increased by 20, and the charge decreased indeed by 1. So indeed, it was this accelerate method here that was used, and that's important to notice, because the car itself also has an accelerate method, right? So we can see that here as well. So in the prototype of the Tesla, we now have accelerate, but in the prototype of that itself, and so that's going to be the prototype of car, we also have accelerate, right? But JavaScript, of course, used the first one. So when there are two methods or properties with the same name in the prototype chain, then the first one that appears in the chain is the one that's going to be used. So the same is true also for the scope chain. And this is the behavior that makes sense. So with this, basically a child class can override a method that it inherited from the parent class. So if we didn't create this accelerate method here, then this would still work, right? Because then the Tesla would simply inherit the accelerate method from the car, right? Of course, now this wouldn't manipulate the charge, it would simply increase the speed by 10. But it would work because it can still find the accelerate method in the prototype chain. But now, as we have this, then this accelerate method will override the one from the parent class. And remember that this is exactly the definition of polymorphism that we talked about at the beginning of this section. And it might seem obvious that it works this way, but it's still good to remind ourselves that we can actually do this. Okay, and with that, we finished yet another coding challenge, and I hope that now it's really clear how we can have one class inherit from another class using constructor functions. And also, of course, the object.create function, because without it, this would be completely impossible. So great job of doing one more coding challenge. Next up, we will see how we can implement the exact same thing using ES6 classes. Let's now go ahead and implement the exact same thing that we did in the last video, but this time using ES6 classes instead of constructor functions. So here again, I copied the initial person class that we built a bit earlier, so that now we can inherit from this class. All right, and so down here, let's now create the student class. So class student like this. Now, as we know already, the class syntax hides a lot of the details that are actually happening behind the scenes. Because classes are really just a layer of abstraction over constructor functions. But that's no problem, because we already learned how inheritance between classes actually works behind the scenes. So that's what we did in the last lecture and the coding challenge. And so now that we know how it works, we are ready to implement the same thing using classes, even though that hides how it actually works behind the scenes. So, to implement inheritance between ES6 classes, we only need two ingredients. We need the extend keyword and we need the super function. So to make this student class inherit from the person class, all we need to do is to say extends and then the person class. So CL, and this one I'm also going to call CL here, just to follow the same name. And that's actually it. So this keyword alone here will then link the prototypes behind the scenes without us even having to think about that. Then, of course, we still need a constructor, and this one will, just like before, receive the same arguments as the parent class, but then some additional ones. So birth year and also the course. Remember? Now here, we actually don't even need to manually call like personcl.call like we did before in the constructor function, remember? So here we don't need to do that. What we do instead is to call the super function. And so super is basically the constructor function of the parent class. So the idea is still similar to what we did in the constructor function, but here it all happens automatically. We don't need to specify the name of the parent class again, because that already happened up here. So here now all we do is to pass in the arguments for the constructor of the parent class, and so that's these two, because that's exactly the parameters that are also specified here in the parent's constructor. Now here in this constructor, so of the child class, this always needs to happen first. So let me even write that here, needs to happen first. And that's because this call to the super function is responsible for creating the this keyword in this subclass. And so therefore, without doing this, we wouldn't be able to access the this keyword to do this. So always first the call to the super, so to the parents class constructor, and from there we will then be able to access the this keyword. Now, of course, we could actually have no other properties here at all. So this is not necessary. I mean, it's not mandatory. And so the same goes for this additional parameter. So in this case, this new student class would simply have new methods and share all the properties with the parent class. So what we're doing here is really just an example, but the possibilities are endless, right? And actually, if we didn't want to do this, then we wouldn't need any constructor function at all. So in this case, the super function would automatically be called with all the arguments that are passed into this constructor. So let me just create a new student here. So that's Martha. So new student CL, let's say Martha Jones, born in 2012 and also studying computer science. All right, but let me duplicate this here very quick, take this one out and only call this with these two. And then, as I was saying, we could have no constructor at all. And this would still work just the same. So you see that now we would end up with a student with the full name and the birth year just as specified. Now remember that this underscore here still comes from this setter function here. So that's what we specified earlier. And so of course, now the student will inherit all of that. Because in the end, these are really just methods too. And so all the students will now inherit all of these methods from the parent class. But anyway, this was just to demonstrate you that if we do not need any new properties, then you don't even need to bother writing a constructor method in the child class. But now let's take this back. This as well, and of course also this. And now let's see if this worked. And yeah, so now we have all the three properties here. Okay, now let's just quickly add the introduce method. So let me copy that from earlier. There's no need to write the same code. So that's the simple console.log that we're going to execute here. So introduce. And so now we can call that on Martha.introduce. And we get my name is undefined here. But that's because here we actually have the full name and not the first name. And so now that actually works. And the same should work for the calcH method that is in the parent class. So Martha.calcH. And indeed, that works as well. And so let's now take a quick look here at the prototype chain one more time, just so you can see that the prototype chain is actually just the same as before when we created it manually. So you see that indeed, in the prototype of Martha, we now have the introduce method. So that's this one right here that we wrote in the class. All right. But now in the prototype of the prototype, we have indeed the calcH method, and also the greet method, and the age and full name setters and getters. And so this proves us that the prototype chain was indeed set up automatically by basically by this extends keyword here, right? Now, finally, just like we did in the previous challenge, let's override one of the methods of the parent class. So let's override the calcH method here. And so all we have to do is to add a new calcH right here. And then let's simply log to the console I'm, and then the age, so 2037 minus this dot birth year, years old, but as a student, I feel more like, and then let's basically add 10 to this date, because when you are in university and you study a lot, then you will feel actually a lot older than you actually are. All right. And so now indeed, this new method overrode the one that was already there in the prototype chain. And again, that's because this new calcH method here appears first in the prototype chain. And so therefore, it is essentially overriding the method coming from the parent class. And we can also say that this calc_h method here is shadowing the one that is in the parent class. And so that's actually it. That's all I have to show you about implementing inheritance between classes using actual ES6 classes. And just to make sure that you got this 100%, I invite you one more time to check out the slides from the previous lecture. So the lecture where we did the same thing using constructor functions. So these slides, these theory parts of the video, I believe are really, really helpful to understanding this. Now, to finish this part of inheritance between classes, let me just say that this mechanism of inheritance that we explored here can actually be very problematic and dangerous in the real world when we are designing software. However, that's going to be a topic for another day, and we're going to talk a little bit about this when we talk about functional programming, which, as I've mentioned a couple of times, is kind of the alternative to object-oriented programming. Anyway, next up, let's do the same thing with object.create. So that's the third way of implementing object-oriented programming in JavaScript. And now finally, let's look at how we can use object.create in order to implement a complex prototype chain, so similar to what we implemented before with classes and constructor functions. And so here I already copied this object here, which will serve as the prototype to create a new person object using object.create. All right, and so of course, this will basically be our parent class. And we already know that object.create is a bit easier to use and to understand, and so it shouldn't be too hard to implement a similar hierarchy between a person and student. So here, person proto, so this object up here, used to be the prototype of all the new person objects. But now we basically want to add another prototype in the middle of the chain. So between person proto and the object. And so what we're going to do is to make student inherit directly from person. So we're going to create now an object that will be the prototype of students. So student proto. And this will be, for now, an empty object. So object.create, and the prototype will be person proto. And that's it. And so now we can use this student proto to create new students. So let's create J and object.create, and it will inherit from student proto. And so now the student proto object that we just created earlier is now the prototype of the J object. So again, the student proto object is now the prototype of J. And the person proto object is in turn the prototype of student proto. And so therefore, person proto is a parent prototype of J, which means that it's in its prototype chain. Whoa, but that once again sounded a bit confusing. And so let's make sure that we really understand this by looking at a nice diagram again. So it all starts with the person proto object, which used to be the prototype of all person objects. But now, using object.create, we make it so that person proto will actually become the prototype of student proto. And what this does is that now, basically, student inherits from person. And so with this, we already established the parent-child relationship that we were looking for. Now to finish, all we need to do is to use object.create again, but this time to create a new actual student object. And of course, we make this student, so J in this course, inherit from student proto, which is now J's prototype. And like this, we created a nice and simple prototype chain. So J inherits from student proto, which in turn inherits from person proto. And therefore, the J object will be able to use all the methods that are contained in student proto and person proto. Now, with the scope chain correctly established, let's also add an init method to student proto. So just like we did here with person proto, so that we don't have to manually specify the properties on any new student object. So let's add that here to student proto.init. So this is going to be receiving the first name, then the birth year, and again the course. And so now we can actually use the same trick that we used before when we use constructor functions. So what I mean is to take advantage basically of this init method so that we don't have to write this same code again. So basically the child prototype can reuse this init method here from the person prototype, which is the parent prototype, right? So that is person proto.init.call, because once again, we want to set the this keyword to the this keyword in this method here. So this, and then the first name and the birth year. And then, of course, we set the course property here, which is unique to the student. So let's now use that method j.init. So j born in, let's say, 2010, and again, computer science. All right, so let's take a look. And yeah, that works. That's nice. And let's now add again the introduce method here, just so that it is similar to the other two techniques that we used earlier. So introduce is going to be a function, and let me just again grab that from here. All right, and now let's call j.introduce. And indeed, that works. And now, as you would expect, we should also be able to call j.calcH, because that method is up here in the prototype chain. And so that has got to work as well. And yeah, so 27. And one more time, just to take a look here at the prototype chain, we see that indeed it has a prototype which contains the init and the introduce methods. So these two that we just created. And this prototype in turn has its own prototype, which is then the one which contains the calcH method. And so that is indeed person proto. So this is exactly the prototype chain that we just saw earlier in the diagram. Okay, and that's actually it. So in this version, we don't even worry about constructors anymore, and also not about prototype properties, and not about the new operator. So it's really just objects linked to other objects, and it's all really simple and beautiful, if you ask me. And in fact, some people think that this pattern is a lot better than basically trying to fake classes in JavaScript. Because faking classes in the way that they exist in other languages like Java or C++ is exactly what we do by using constructor functions and even ES6 classes. But here, in this technique that I just showed you with object.create, we are in fact not faking classes. All we are doing is simply linking objects together, where some objects then serve as the prototype of other objects. And personally, I wouldn't mind if this was the only way of doing OOP in JavaScript. But as I mentioned earlier, ES6 classes and constructor functions are actually way more used in the real world. But in any case, it's still super important and valuable that you learned all of these three techniques now, because you will see them all in the real world still. And this also allows you to think about this on your own and choose the style that you like the best. But again, in the real world, and especially in modern JavaScript, you will mostly see ES6 classes being used now. And so, since I want to prepare you for the real world, I will start using classes from this point on. There are a few more things that we need to learn about classes. And so let's actually create a new class now. And as an example, we are going to use the bank account that we implemented before in the Bankist app. Remember that? So let's say class account. And then, as always, we need the constructor method. And here, each account should have the owner name. It should have a defined currency. And also, we want to pass in a PIN. And so let's say this.owner is owner, and the same for currency and the PIN. So we already know how to do all of this, right? And so now let's create a new account here. Let's say account 1. And so new account, and let's say that I am the owner, so Jonas. Then the currency is in euro, and the PIN, let's say, is this one. All right. So indeed, we have the 3 values that we passed into the constructor now inside of the object. But now, what about the movements array and maybe also the locale? So we want to start always with an empty array as the movements, and the locale we want to get from the navigator.language. So how should we do that? Should we add a new parameter like this? So movement, and then always pass in like an empty array in all the accounts that we create? Well, that would work. So let's actually see that. So movements should be equal to movements here as well. And so now, as you see, the movements is now this empty array. However, it doesn't make much sense to pass in this empty array into all the new accounts that we want to create, right? So we don't need this, and instead we can simply do this. And so this is something that we didn't do before, but of course we can create even more properties on any instance and properties that are not based on any inputs. And the same we can now do for the locale and set it to navigator.language, right? And so now all of that appears here as well. And in fact, we can even execute any code here in this constructor that we want. So let's say, thanks for opening an account. And then owner. And so when Jonas opens a new account, then he is basically greeted with this message here coming right from the constructor. All right. But now what about the deposits and withdrawals? So basically, what about our movements? Well, we could simply now go ahead and do this. So we can take account1.movements, and then if we wanted to do a deposit, we could push a value into this, let's say 250. And then when we wanted to withdraw something, we would simply push a negative value. And so if we then take a look at our account here, then of course we would see these movements right here in our array. However, it's not a good idea at all to do this. So instead of interacting with a property like this, it's a lot better to create methods that interact with these properties. And that is especially true for important properties such as these movements here. So this will for sure avoid bugs in the future as your application grows. So let's now actually create a deposit and a withdraw method here. So deposit, and then here the value that we want to deposit, and then this dot movements dot push the value that we pass into. And now the same for withdraw. So also a value. And so here we can now actually call this method, because it's actually going to work basically the same way. So this dot deposit, and so as you can see here, we can actually call other methods inside of a certain method. So in withdraw, we are calling this dot deposit. But of course, we still need to use the this keyword to be able to access this other method. And then here we pass in minus the value that we received in this function. So let's try this now. So instead of doing this, we now can do it in a much nicer way. So account1 dot deposit 250, and then account1 dot withdraw 140. And so indeed, our movements array looks just the same as before, but now we are actually using this public interface that we built here, right? So basically, these methods here are the interface to our objects, and we also call this API, remember? So we talked about this right at the beginning of this section. So again, let's actually write this here. So this is the public interface of our objects. And so, yeah, this is a lot better than having to manually manipulate these properties outside of the object as we did here. Also, this withdraw method here actually abstracts the fact that a withdrawal is basically a negative movement. So here, as we did it manually, we needed to pass in minus 140. But now, as we do a withdrawal, it's of course a lot more natural to write that simply 140 are going to be withdrawn. So what I'm trying to say is that this minus here is something that the user of this object shouldn't be caring about. And so now we actually abstracted that away right into this object, and in particular into this withdraw method. So just a very small abstraction here in this case, but it's still worth to notice. All right. Now, of course, still there is nothing stopping someone on our team from interacting with the movements array directly and potentially making mistakes and introducing bugs. So simply the fact that we have these methods doesn't make it impossible to still do this. And the same goes, for example, for the pin. So, of course, we can access the pin from outside of the account. So, you see, but probably it shouldn't be accessible from outside of the class. But yeah, of course, right now it is accessible. And this is actually a very real and very important concern. So it's not just something theoretical that I'm telling you here. And the same, of course, goes for methods. So let's say we have a request loan method here for some value. And remember that this was also a functionality of the Bankist application. So we could make the approval of the loan based on some condition. And that condition could come from some other method. Let's say approve loan. Let's pass in a value here as well. And this one will simply always return true. So I don't want to implement any complex logic here now. But anyway, here we can now call this dot approve loan with the value. And so if the loan is approved, then this dot deposit of the value, and we can log something to the console. So loan approved or something like that. Okay. Now in the public interface, we basically only want this method here. So we want to be able to do this here basically, account1 dot request loan, let's say of 1,000. And so we see that the loan was approved and it was pushed into our array. But of course, we are also able to do this. So approve loan. And so this, of course, doesn't do anything. But in the real world, we should not even be allowed to access this kind of method. So this is kind of an internal method that only the request loan method should be able to use. And so the reason why I'm telling you all this is basically just to justify that we really need data encapsulation and data privacy. And we talked about these topics in the introductory lecture of this section. And so as always, you can go ahead and review that. But anyway, in the next video, we will finally start implementing data privacy and data encapsulation. So let's move on there right now. In the last lecture, we implemented a new class which showed us the need for encapsulation and data privacy. So let's now tackle this very important principle of object-oriented programming. Now, first, remember that encapsulation basically means to keep some properties and methods private inside the class so that they are not accessible from outside of the class. Then the rest of the methods are basically exposed as a public interface, which we can also call API. So this is essential to do in anything more than a toy application. Now, there are two big reasons why we need encapsulation and data privacy. So first, it is to prevent code from outside of a class to accidentally manipulate our data inside the class. And that's exactly what we did by the end of the last lecture here. So this is also the reason why we implement a public interface. So we are not supposed to manually mess with this property, and therefore we should encapsulate it. Now, the second reason is that when we expose only a small interface, so a small API consisting only of a few public methods, then we can change all the other internal methods with more confidence. Because in this case, we can be sure that external code does not rely on these private methods. And so therefore our code will not break when we do internal changes. So that's what encapsulation and data privacy are and the reasons for it. And so let's now actually implement it. However, JavaScript classes actually do not yet support real data privacy and encapsulation. Now, there is a proposal to add truly private class fields and methods to the language, but it's not completely ready yet. I will still show it to you in a next lecture because it's really cool, but even when this feature ships in the browser, it will take some time until you can use it with confidence. And so in this lecture, we will basically fake encapsulation by simply using a convention. So the first candidate to protect here is again this movements array that we have been talking about. So the movements are mission critical data, and so here we will protect this data so that no one can accidentally manipulate it. And for now, all we will do is to add this underscore in front of the property name, and that's it. Now we need to then go ahead and change it everywhere. So that's here. And yeah, that's actually it. So again, this does not actually make the property truly private because this is just a convention. So it's something that developers agree to use and then everyone does it this way. But since it is not truly private, we call this protected. So protected property. And so now if we wanted to get the movements outside here, we could of course still do this. So that's what I was just saying, which is that the data here is of course still accessible if we use this underscore outside here as well. But at least now everyone on your team, and that includes yourself, will know that this property is not supposed to be touched outside of the class. So you can still do it, but at least you will know that it is wrong, okay? Now, if we still wanted to give access to the movements array from the outside, then we would have to implement a public method for that. So let's do that actually right here. So let's say get movements. And of course, we could also create a getter here instead of this method, but let's just keep it simple. So it's very common to actually have a method that is called get or set instead of using a real getter or a real setter. And so all that this will do is to return this dot movements. And so now this would be the correct way to get the movements. So get movements. And so this one, everyone can still at least access the movements, but they cannot override them. So they cannot set the movements. Unless, of course, they use the underscore with the convention, but then at least they will know that it's wrong to access the property. Next, we could also protect here the pin. So this is also something that doesn't make much sense to be accessible from the outside. And in fact, we could make everything protected here, but I think that like this, we are good to go. So this is just a small example anyway. And so for now, let's leave it like this. To finish, let's just also protect then the approve loan method. So this one I also mentioned by the end of the previous lecture. So this is a method that is only supposed to be internally by the bank, let's say, basically just to check if a loan should be approved. So essentially, this method here should not be part of the public API, but all the others should be. So right now we are protecting this method, and so our public API right now consists of these other 4 remaining methods. All right. So this is how we protect fields from unwanted access. Now, as I said, of course, developers need to know about this convention and need to follow it, because otherwise everything will still be public. But now in the next lecture, we're actually going to talk about truly private fields and methods. And so with that, we will then fix this problem for good. All right, so let's now implement truly private class fields and methods. So private class fields and methods are actually part of a bigger proposal for improving and changing JavaScript classes, which is simply called class fields. Now, this class fields proposal is currently at stage 3, and so right now it's actually not yet part of the JavaScript language. However, being at stage 3 means that it's very likely that at some point it will move forward to stage number 4, and then it will actually become a part of the JavaScript language. And that is probably going to happen some point soon in the future. And that's why I decided to already include class fields in this course. And in fact, some parts of this proposal actually already work in Google Chrome, but other parts don't. At least not at the time of recording this video. Now, for starters, why is this proposal actually called class fields? Well, in traditional OOP languages like Java and C++, properties are usually called fields. So what this means is that with this new proposal, JavaScript is moving away from the idea that classes are just syntactic sugar over constructor functions. Because with these new class features, classes actually start to have abilities that we didn't previously have with constructor functions. And many developers consider this to be a big problem, but personally, I'm not sure if it is such a big deal for the average JavaScript developer. So as long as you still understand how prototypal inheritance and function constructors work, then I believe that you will be fine. But anyway, no matter if you end up using these new class features, let's now start exploring them. So in this proposal, there are actually 4 different kinds of fields and methods. And actually it's even 8, but in this video I'm just going to focus on these 4. And that's public fields, that is private fields, and then we have public methods, and we have private methods. So essentially there is a public and a private version of both fields and methods. And let's now start with public fields. So we can think of a field as a property that will be on all instances. So that's why we can also call this a public instance field. So basically in our example here, the 2 fields could be the movements and the locale, because these are basically 2 properties that are going to be on all the objects that we create with this class. Because we do not pass any of the values here in, so into the constructor, and so this array and this language, they will always be set for all the instances, right? And so let's now add them as public fields. So that works simply like this. We can say locale equal and then navigator dot language. And then here we actually need to write a semicolon, which is kind of weird because between these methods, we do not need commas or semicolons. What's also weird is that this kind of looks like a variable here, right? But we don't have to declare it using like const or let. So this is how we simply define a public field. Let's write that here. So public fields. And the other one is going to be this movements. And I will still, for now, call it underscore movements. And so I'm setting it to this empty array now. And so when we reload this now, you will see that then the account here works exactly the same. So we still have the locale here and also the movements. But now they are actually public fields. But in our final object here, that doesn't make any difference. Because again, these public fields here are going to be present on all the instances that we are creating through the class. So they are not on a prototype. So this is important to understand. So all these methods that we add here, they will always be added to the prototype, right? But again, the fields here, they are on the instances. Let me write that here as well. And so again, having this here is essentially exactly the same as this. And therefore, these public fields, they are also referenceable by the this keyword, and they are also referenceable via the this keyword. Great. So that's public fields. Next up, let's talk about private fields. So this is number 2. This is number 1. Let's add that here as well. So just to keep a nice overview of all the things that we are learning here in this lecture. All right. So private fields is the one that we have actually been waiting for. So with private fields, we can now make it so that properties are really, truly not accessible from the outside. So just like in the last lecture, let's start by now finally making the movements array private. So let's move it here. And now I will remove the underscore, and then I will use the hash symbol. And so this is the syntax that makes a field private in this new class proposal. So let's try and reload to see what happens now. And indeed, we get some error. And the reason for that is that the property is now really called hash movements. So we need to change that everywhere. So both here and here. Yeah, that's it. Give it a save, and now it all works. So let's see. Here we now actually have the movements in this array, which is called hash movements now, basically. And so now we are finally going to be able to see that this property is indeed protected. So if we try to read account1 dot movements, then we get a syntax error. So private field movements must be declared in an enclosing class. So basically JavaScript thinks that I'm trying to implement this private class field out here, and that's the reason for this error. But what matters is that in fact we cannot access this variable outside here. And of course the movement property from before does now no longer exist. So we get undefined there. Now the error message here might look different for you by the time that you're watching this video. Because as I said, this proposal at the time of recording is not really finished yet. And so some implementation details might still change. And so that might also affect the error message here. And speaking of implementation, I believe that right now only Google Chrome actually supports these private class fields. And so make sure to also test your code in Google Chrome. But anyway, the movements are now truly private and no longer accessible outside here, at least not by their property. We do still have, of course, this method here in our public API. And so this one we can still use to get the movements. So that's right here. And that was indeed the whole point of creating this method in the first place in the last lecture. Now the next candidate to make private is this pin. So in the last lecture we protected it, but now just like the movements, we want to convert it to a truly private field. However, this time the situation is a bit different, because now we are actually setting the pin based on this input value to the constructor. However, we cannot define a field in the constructor. So the fields, they really have to be out here, outside of any method. So what we have to do is to create the field out here, so the private field, again with hash, and then don't set it to anything. And so this is essentially just like creating an empty variable. So in the beginning, this will be set to undefined, and then here we can redefine that value basically. And so one more time, we can see that these class fields are really just like any other property. That's why later down here, we can then access it on the this keyword and set it to the value that we received. So let's try that. And indeed, the pin here is now also a protected field, or actually a private field. And so when we try to access it, we will no longer be able to do that. All right. So that is truly private class fields. And again, these are going to be available on the instances themselves. So not on the prototype. And so, yeah, of course, that's why we have them right here in the instance. Now, some people don't like the way that the syntax looks here with the hash symbol, and there has been a lot of discussion going on. Now, I don't mind it at all. I just like to focus on the benefits that this new syntax gives us. There is a slight change that it might still change before the proposal reaches stage 4, but in this case, I will simply go ahead and update this video. But anyway, next up we have public methods. And actually, that is nothing new at this point. So all these methods here that we have been using are indeed public methods. So in this case, there is not a lot to talk about. And in fact, we had already written something similar here. So saying that all of these methods together are basically the public interface of our class. And so therefore, let's move on to our final point here, which is private methods. So let's do that down here. And private methods, as we already mentioned earlier, are very useful to hide the implementation details from the outside. And that's why in the previous lecture, we already made this method protected with this underscore. And so let's now grab this and put it down here. And now to make a private method, the syntax is exactly the same as private fields. So just like with the hash. Now the big problem here is that right now no browser actually supports this. So I can just show you how it works in the code, but unfortunately I cannot show you how it works. So if I save this now, I will probably get some error. And so yeah, the first one is that this function now no longer exists. So let's change that here as well. And well, we don't get any error actually. So that's surprising to me. Let's see what we have here. So indeed, here we have the approve loan now. So I guess that right now Google Chrome simply made this method like a private field. So that's why it no longer appears in the prototype. Right? So it's not here, but now it's instead on the instance. So that's not really what we want. Let's just test if we can access it out here. So console.log account1 dot approve loan with some value, and then we get the same error as before. So private field approve loan. And so yeah, it's just as I said. So Google Chrome right now basically sees this as a private class field and not as a method. And so that's why I was saying that the methods are not really yet implemented in Google Chrome. So private methods are not available. And so let me just leave it here as a comment, but I will go back to simply protect it with the underscore convention. All right. So at some point in the future, this will work. But for now, let's leave it just as it was before. Okay. So we talked about these 4 features here. So public fields, private fields, public methods, and private methods. Now, besides these 4, there's also the static version of the same 4. And that's why I said in the beginning that actually we have 8 new features. So there's also the private version. And actually, and that's not private, that is static. All right. And actually, we already used the static public method before. And so that worked by simply adding the static keyword in front of it. Remember? So just static and then some method name. And so usually we use this for helper functions, because these static methods will not be available on all the instances, but only on the class itself. Remember? So this static one here only works like this. So account.helper. And so, as I said, there's also a static version for all the other 3 ones. But I'm not going to show them to you now in this video, because they are really less important. And if you want, you can of course easily test them out by yourself. Okay, and that's actually it. So this is how we implement encapsulation and data privacy using the new class fields proposal that hopefully at some point will really become part of the JavaScript language. Do you remember how we chained array methods one after another? For example, filter, map, and reduce. So by chaining these methods, we could first filter an array, then map the result, and finally reduce the result of the map all in one line of code. And we can actually implement the same ability of chaining methods in the methods of our class. And so let's go do that now. And actually, this is extremely easy to do. So all we have to do is to return the object itself at the end of a method that we want to be chainable. So let's say that we wanted to do this. So let me take that away from here. So chaining. So let's say we wanted to do account and then deposit, let's say 300. And then right afterwards, we wanted to deposit again on the same account. So we would like to call deposit again right away. Let's say 500 this time. And then immediately after that, let's say we want to withdraw 35. Maybe we also want to request a loan in the middle of this. So request loan, let's say 25,000. And then finally, we want to withdraw some more. Let's say 4,000. So right now, this is not going to work. So let's see the error. And so the problem here is that this one here will work, but this will then return nothing because, let's see, the deposit method does return undefined because we're not returning anything explicitly here. And so then undefined gets returned. And so then here in this next one, we are trying to call the deposit method on undefined, which is the result of all this. And therefore we get exactly that error here. So what we need to do is to call deposit actually on an account. And so what we want is for the result of this here to be again the account, right? And so let's do that. So all we have to do is return this, because this is of course the current object. And now we do the same on all of them. Okay. And here the same. And that's it. So returning this will essentially make the method chainable. And this makes most sense in methods that actually set some property. And so all of the three that we just did this actually do that. So this one sets the movements here, this one actually too, and this one also changes the movement array. And so all of these basically set some property, and so these are then very useful to make chainable. So let's see now. And, well, we get no error, and we get loan approved. So that means that probably everything worked here. So let's take a look at our account here. Actually, let's call account get movements. So that's why we have this method in a public API. And so indeed, all the deposits and withdrawals that we just did are now in this movements array. Great. So with this, you have yet another tool in your toolbox now. So experiment a little bit with this on your own, and maybe also when you start writing your own classes. All right. So with this one, I actually showed you all there is to show about object-oriented programming in JavaScript. So what a long section here, but also a beautiful one, if you ask me. Now, just to really wrap up this section, next up I have a nice overview of the entire class syntax, and then one final coding challenge. So as we reach the end of this section, let's quickly review all the terminology around classes, because there is so much different stuff going on, so a lot of different features that you can use. And since classes are probably the way you're gonna implement OOP by yourself, it's always good to have a nice overview of everything that we can do with them. So here we have a huge class which essentially contains all the features that we studied over the last couple of lectures. So this is how we define a class, and in this case it is actually a child class. So student is a child class of the parent class person, and that is because here we are using the extends keyword to set up the inheritance between these two classes. And remember that the extends keyword will also automatically set up the prototype chain for us, so we don't have to do anything manually. Next up, this is how we define a public field. So this is what we did in a very recent lecture. And so remember that a public field is very similar to just a property that we defined in a constructor. So it is available on every created object, so on every instance created by this class. Then, of course, we also have private fields, and they are almost the same as public fields, but they are not accessible outside of the class. And so therefore, this is perfect for implementing data privacy and encapsulation. We also have static public fields, and so these are fields, or like properties, that are available only on the class. And I didn't show them to you in the code, so in one of the lectures, but this is how we can implement them. So just like static methods, we use the static keyword to make any field static as well. Then here, this is the constructor method, and it is automatically called by the new operator whenever we create a new instance of the class. So basically a new object. And this constructor method is mandatory in any regular class, but it might be omitted in a child class if we wanted to have the exact same number and the exact same name of parameters. Then inside of the constructor, there is the call to the parent class, and so that is the super class. And this, of course, is only necessary whenever we are writing a child class. So when we're using the extend keyword. And remember that this one needs to happen before we can access the this keyword in the constructor. Then here we have an instance property. And so just like public fields, the property is also available on each created object. But the difference between this one and the public field is that we set these instance properties based on input data of the constructor. So basically, these properties are more personalized and unique for each object, while the fields are usually for something that is common to all the objects. For example, here, the university for all of the students is the University of Lisbon. And so that is not unique to each object. Okay? Then here we are redefining a private field. And so this is what we did with the PIN in the bank account example, right? So this private field should be unique for each student. And so we created the private field out there without any value. And then here we are simply redefining it to the value that is coming into the constructor. Then here, as we already know, is a normal public method. Here we are referencing a private field and also a private method. And so about the private methods, this is how they look like. But as I mentioned, they will probably not yet work in your browser, at least if you're watching this close to the recording date of this course. So as an alternative, you can fake private methods by using the underscore convention instead of the hash. Next up, this is what a getter method looks like. And remember that a getter method is basically so that we can get a value out of an object by simply writing a property instead of writing a method. So in this case, we could simply write student.testscore, and that would then run this getter method. And the same for the setter method. So in this case, we can simply define the test score by setting it to some value instead of calling a test score method. And keep in mind that if you have a setter for a property that is already defined in the constructor, then you need to create basically a new property with the underscore in front of it. So again, that is kind of a convention that you should use in this case. And then in the getter with the same name, you also need to then return that new property. So we did that in one of the lectures when we did a name validation for the name that was passed into the constructor. Remember that? Next, this is how you write static methods. And a static method is available only on the class. So it cannot access the instance properties nor the methods, but only the static ones. So for example, that static public field that we defined there in the top will of course be accessible in the static method. And usually we use these static methods as helper methods for the class. Finally, this is how you then create a new object using the new operator. And so this should be nothing new at this point for you. Now, here is just a couple of things that we need to remember about classes and that I actually already mentioned before as well. So keep in mind that classes are really just synthetic sugar over constructor functions. Also, classes are not hoisted, they are first-class citizens, and the class body is always executed in strict mode. Okay? And there you have it. This is an overview and also a summary of the entire syntax of classes in JavaScript.